Lesson 1.7, solve absolute value equations and inequalities. Absolute value is the distance from 0. For instance, if I had the absolute value of -4 and the absolute value of 4, both are equidistant from 0 or to 0, and I'll show you that on a number line. So when I take the -4 out of the absolutes, it's 4, 1, 2, 3, 4 places to 0. I take out the +4 from absolutes, and it's still 4, 1, 2, 3, 4 places to 0. We know inside the absolutes could solve to be either positive or negative, because the solution will come out positive either way, like the example above that we discussed. So we're going to solve it twice. I have it written x plus 5 equals 3, and then we have x plus 5 equals -3. And now we're just going to subtract 5 from both sides. So x equals -2, subtract 5, x equals -8. Now when I put the -2 and the -8 back into the original problem, we should get true solutions, and I'll show you that. Okay, so I wrote the original problem twice, and I just left parentheses where we're going to sub in the -2. So we end up with -2 plus 5 is, the absolute value of 3 is 3. So that's true for -2. When we sub in the -8, we have the absolute value. So -8 plus 5 is -3 equals 3. And that is also true because when we take out that -3, it's going to be a +3. Let's try one that has more steps. First, we're going to get the absolutes on one side. So we're going to isolate it. So we're going to add 10 to both sides. So we end up with 3, absolute value x minus 2 equals 21. And then we're going to divide both sides by 3. So we have the absolute value x minus 2 equals 7. Now we're going to write it 2 times and solve it, therefore, twice. So I wrote it twice. The left-hand side, we have a +7, and on the right-hand side, you'll notice we have our -7. So when we solved, we ended up getting x equals 9, x equals -5. When I put those values back into the original problem, we should get a true solution, and I'll show you that. Okay, so here we have the original form of the equation. We substituted in the 9. 9 minus 2 is the 7. 3 times 7 is 21 minus 10 equals 11. And I kind of ran out of room, but 11 equals 11 is what it comes out to. Then we'll go over to the right, and you'll see that we have -5 minus 2, so that's really 3, and we end up with a -7 in the absolutes. Minus 10 equals 11. But when I take out that -7, it's really a positive. So +7 times 3, we still get 21 minus 10 equals 11. So that one is also true. Now you'll notice that we have absolute values and an inequality, and that the inequality is greater. And I say greater because when we have a greater than symbol, we're going to create an or statement. And when we worked with compound inequalities in the last lesson, we talked about or and. So we're going to solve it twice. So before we begin to solve, you'll notice that on the right-hand side, I have my -5, but I also changed my greater than symbol to a less than symbol. Think of it as when we multiply or divide both sides by a negative, when we're working with inequalities, we switch the symbol or reverse it. That's what we did here. So then we're going to solve as normal. We're going to add 3 to both sides. I want to put the word or in between. So 2x is greater than 8 divide both sides by 2, x is greater than 4, and add 3 to both sides. 2x is less than negative 2, divide both sides by 2, x is less than negative 1, and now we're just going to go ahead and graph it. Okay, so remember it was an OR statement. This is my solution. X is greater than 4, so remember it's hollow, and we highlight everything that's greater than 4, and then x is less than negative 1, so it's hollow, and we highlight everything that's less than negative 1. Okay, one more example to try. So for this one, we have less than. So how you can remember this one, less than is an AND statement. So we're going to end up with one big inequality, one big compound inequality. Okay, so I wrote my two inequalities, and I remembered that when I included a negative 6 that I had to reverse the symbol, and then I wrote it using or just as one big compound inequality. So the negative 6, that's the smallest value, that goes on the left just like it would on a number line, and of course the positive 6 is over here on the right. And then we start by subtracting 3 from all parts. So negative 9, and then we're going to divide everything by 2. So in this case we ended up with a fraction. Negative 9 halves, we have a less than x, and 3 halves. So this is my solution, and now we're going to graph it. So we'll do that. We start reading at the x, so x is greater than negative 9 halves, so we started highlighting everything that was greater, and then we go back to the x. X is less than 3 halves, so we start at 1.5 and we start highlighting everything that is less. And again, we didn't have an equal to bar underneath the symbol, so they remain hollow.